Hello students. Ooh, hello. I'm making this video for my students who are on the psych field trip so that you don't get too far behind. So our objective for today, the 24th of October, is to solve linear systems by elimination. Another way of saying that is by linear combination. So we have our warm-up, we check our homework, we take some notes, practice, and active votes, which we didn't quite get to today, but we did practice and do some problems. So the warm-up is asking you to use substitution to solve the linear system. So if you can hit pause on your video for a second and try that using substitution method, which we learned on Tuesday, and then the answer will pop up. So hit pause now, try it. The answer is right here, 6, 4. Now I used one method of just solving for 3y and then substituting in what 3y equaled, and another student chose to solve for x and plug in what x equaled right here. But be really careful with that negative distributing. So check and see. If you didn't get 6, 4, maybe come in and talk to me and we'll figure out substitution. Okay? All right. Oops. Sorry. I think, no, it was okay. Okay. So we've already learned how to solve linear systems by graphing and by substitution. And today we're going to look at elimination or linear combination. Now, I like to take my students to kindergarten, then to first grade, then to algebra 1, then to algebra 2 to help you with this concept that we're doing. Now, right here, square equals square and circle equals circle. But really, let's think of this a little more maturely. Like this is a weight, and this is a weight. Like these two shapes have the same weight, and these two circles have the same weight. So they are equivalent, or they're equal to each other. If I was to add these two things straight down, I would get square plus circle equals square plus circle. So I have a true statement, and if I add those two true statements together, I get another true statement, that a square plus circle is equal to a square plus circle. This weight on this side is still balanced with this weight on that side. All right, so let's take it. This is kindergarten. We're going to go to first grade. Well, nowadays, I think they're doing this in kindergarten too. I don't know. You guys are getting so smart so quickly. Here we go. So 2 plus 3 is 5. I think you'd all agree to that. 7 plus 8 is 15. We have two true statements. We're going to add them up, but we're going to add this way. So we're going to go 2 plus 7 is 9. 8 plus 3 is 11. And notice I'm bringing down my plus sign. I'm bringing down my equal sign. 5 plus 15 is 20. All right. Is this a true statement? 9 plus 11 equals 20. Yes, I still have a true statement. So this is something I don't think we've ever done before. We have seen it in Algebra 1, but I just wanted to remind you of this concept. This is linear combination. We're adding two different equations, and notice there are no variables, but we're going to get there. Okay, so let's move to Algebra 1. Oh, one last thing, sorry. We are also allowed to do the same thing to both sides. So here, I could say, well, let's multiply both sides by 2. As long as I do the same thing to both sides, I'm still going to have a true statement. So 5 times 2 is 10. And I left space down here so I could rewrite this equation. 2 times 2, this distributes. 2 times 2 is 4. 2 times 3 is 6. All right, now I've already dealt with this equation, so I'm kind of done with that. I transformed it into this twice whatever it started with, and I'm going to add up these new equations. 7 plus 4 is 11, 8 plus 6 is 14, and 10 plus 15 is 25. Is this a true statement? 11 and 14, 10, 25. Yep, it's still a true statement. So these are things that we're allowed to do. We're allowed to multiply both sides by the same number, and we can combine linear equations. All right. So let's look at Algebra 1 stuff. All right, this is what we did in Algebra 1. And the very simple problems help you get the concept, and then we can move on to the more challenging stuff. So if we add these two up, let's see what happens. X plus x gives us 2x. Sorry, if I'm going too fast, you can hit pause and copy this down, but I don't want the video to be like 30 minutes long, so I'm moving a little quickly. All right, so x plus x, we get 2x. If I add up a negative y and a positive y, I get 0y. So that really just cancels out, or eliminates itself. Okay, and then 1 plus 3 is 4. Check that out. That was really quick. I already have a one-step equation, x equals 2. Divide both sides by 2 to get x equals 2. And that's half my answer. Now in order to get my whole answer, I need to plug 2 back in. I'm going to use this equation. So I do plug 2 in for my x, plus y equals 3. Subtract 2 from both sides, and y equals 1. So my solution to this system of equations, if I were to graph that, the point where they intersect would be 2, 1. And that would be my solution. Now if I wanted to check my answer like I'm going to do, like you're going to do on your test or your quiz coming up next Monday, you're going to plug this x and y back into both equations and check. Make sure that they make true statements. Okay? All right, so this is something we learned in Algebra 1. What about over here? If I go to add these up, so let's see, x plus x is 2x, and this plus this, we get negative 2y equals 22. Sorry, that's an equal sign. Okay, well, over here, our y's disappeared. Nothing disappeared. So we have a little problem here. Let's see, is Eraser gonna make a big mess? Oh, sorta, kinda. Quick fix. Whoop. Okay. So, that's not gonna work. What we need to do is first multiply through by something. Now, I could multiply both sides of this equation by negative 1. Or I could multiply both sides of this equation by negative 1. Why would I want to multiply by negative 1? What is the purpose of that? Well, let's do it and see what happens. Negative x minus 4y equals negative 11. All right, so I have this changed equation. I multiply both sides by negative 1, and then I have x minus 6y. I'm just copying down the second equation so I can see a little better. All right, so now let's add them up and see what happens. Negative x plus x, they cancel out. So this is y. This is the y. Why would I want to multiply by negative 1? Well, I need these to be opposite numbers, opposite coefficients. The number in front of that variable has to be a negative 1 and a positive 1 in order to cancel out. Here I get negative 10y equals 0. Divide both sides by negative 10, y equals 0. All right, I've got half my answer. Plug this back in. 4 times 0 is 0, and x equals 11. Did you get that? X. I'm going to plug in my 0 from down here. Equals 11, and this whole thing becomes 0, so x equals 11. And that would be my solution. 11, be careful about your order. I was about to put 0 first. But 0 is my y value, and 11 is my x value. So my solution would be 11, 0. All right, now these are simpler than the ones we're going to see. So let's go see some more Algebra 2-like ones. Oh, too many slides. Sorry. There we go. All right, so elimination using multiplication. So as you notice here, nothing simplifies right here. I need to multiply through by something. And in class, I guess it was my 6th period class, they said, they had a little argument, but it was a good argument. They said, one student said, I would multiply the first equation by a 2. They said they would take this first equation and multiply by 2. And I said, great, go ahead and do that. So half the class did that. And then the other half of the class went with the other student. Should I name students' names? This was Josh and Josh and who? Augustina and Josh. They told me, one told me to multiply through by a negative 5. Negative 5 on this side and negative 5 on that side. Josh told me to do that. No, Augustina said to do that. All right, and over here, Josh said, well, it'd be easier just to multiply by 2. So the question is, Are they both right? Are they both wrong? Can you do that? Is this allowed? What's happening? So let's try this one. If I multiply 2 here and here, what's going to happen with this? 2y minus 2y, what happens there? Exactly what I need to happen, right? So that will work. 2, 2, and I'm also multiplying this by 2. So all three pieces get multiplied by 2. So I end up with 2x plus 2y equals negative 18. That's my first equation changed. I multiplied it by 2. So we rewrite the second equation exactly as we saw it. 5x minus 2y equals 32. I didn't have to multiply the second one. Now in the future you might have to, but right now we're good. Okay, add up these things, we get 7x equals, add those up, so we get 14 divided by 7, and x equals 2. Alright, so this method that Josh suggested was good. It worked. Alright, what about Augustina? If we multiply negative 5 here, minus 5, so be careful, it distributes both places, minus 5y equals a positive 45. Alright, and then we rewrite the second equation, 5x minus 2y equals 32. Alright, again, we're going to add up these two equations. These two, now here we have the x's canceling out, and the y's are remaining. Negative 7y equals 77. Divide both sides. And y equals negative 11. Alright, so both of them give us a valid part of our answer, right? So either method works. Here I'm going to plug my 2 back in. So I'm going to plug my 2 into my original equation. 2 plus y equals negative 9, and find that y equals, subtract 2 from both sides, negative 11. Aha! Same thing as I got over here. Alright, if I plug y into that first equation, x plus y, which is a negative 11, equals negative 9. Add 11 to both sides, and I get 2 equals x. So notice, same exact solution. 2, negative 11. 2, negative 11. So you don't have to do your problem two different ways every time. I was just showing you that half my class did it one way, half my class did it the other way, and they both got the same answer. Okay? Alright, let's look at some more. Oh, I think it's the steps next. Alright, I don't tend to teach it with the steps because I think seeing it is better, but if you are a person that likes to see the steps, here's some steps for you. Multiply one or both of the equations by a constant to obtain the coefficients that differ by a sign, right? So we need one positive 4, one negative 4 in order for them to cancel out. Or more specifically, positive and negative for x, or positive and negative for y. Step 2, add the revised equation and combine like terms. It should eliminate one of the variables. That's the key. This is the elimination method, or the linear combination method. So we solve for the remaining variable and substitute that back in to find the other variable. Alright, if you need more time to write that down, hit pause and you can copy those down. Alright, here is with, sorry, a little tongue-tied there. Go ahead and try this one. Hit pause and try it, and then I will have some of the answer there so you can check your work. Okay? Alright, go ahead and hit pause. So I just did the first step here. Multiplying the first equation by 2 would be a good option because that would help my x's be eliminated. When I add these up, these cancel out. I get y equals 6. Once I have that, I can plug that back in to either equation. I'll pick the first one, plus 2 times 6, which is my y value, equals 6. So we have 12. Subtract 12 from both sides. Divide, and x equals negative 2. Alright, so our solution would be negative 2 6. If I graphed those equations, if I solved these for y, and I graphed them, they would intersect at the point negative 2, 6. Another way of looking at it, negative 2, 6 satisfies this equation. It makes this a true statement. It also makes that a true statement. Okay? All right. Next one. This was a challenge, and my class looked at this and said, that doesn't look very challenging. All right, so let's try it and see why. Why is this challenging? So I see, 2 and 4 and 1 and 2. We can get those to be opposites pretty quickly. So if I multiply this through by negative 2, then we're pretty good. Let's try this. I'm just going to put it below. Negative 2x plus 4y equals 6. All right, so let's add them up. This plus this is 0, and that plus that is 0, and that plus, oh, sorry, I forgot my negative here. That plus that gives me 1. So I get 0 equals 1. What do we think about that? Okay, so this is why it's a challenge. 0 equals 1. Is that a true statement? We have to ask ourselves, is this a true statement or a false statement? Obviously, 1 and 0 are definitely different amounts. So this is a false statement, which tells us there are no solutions. Now, should I have gotten something that was a true statement, like 0 equals 0 or 1 equals 1, that would be a true statement and there would be infinitely many solutions. So it would be the same exact line. So these lines are parallel. If I solve those and graph them, no solution means we're going to have parallel lines. They never intersect. Okay? All right. I think that's all for my video. This is number 2 on your homework assignment. We were discussing all the different options. How could we get them to be the same? Because in this situation, you need to multiply both equations by a number. Sorry, let me clean that up a bit. Can I get that out of there? And get that out of there. Sorry, I should probably have paused the video, but that's okay. All right, so here we go. In order to get these the same, we want to look maybe at the 6 and the 4. All right, one student suggested, what if we multiply this equation by 1.5? And I was like blown away. Oh my gosh, that's so interesting. I never would have considered that as an option. Multiplying this by 1.5 would get it to be a negative 6. I was very impressed. Good job, Alejandro. All right, now there are lots of other ways you could do this. You could think, okay, 6, if you think about factors of 6, you want to find the lowest common multiple. So 6, 12, 18, you could keep going. Now 4, I've got 4. Start with 4, then 8. Sorry, that's a 4. 4, 8, 12. Oh, I already see one in common. 16. So 12 would be a good number. We could make this into a negative 12 and make that into a positive 12. In order to do that, here I'd have to multiply times 3. 3 times 4 is positive 12. And here I'd have to multiply by 2. But remember, whatever I do to this side of the equation, I have to do the same thing to both sides. Here, if I multiply by 3, I have to also multiply by 3 over here. All right? Then you set up your new equation, add them up. If one of the variables doesn't disappear, then something happened with your math. You need to go back and check. Okay? Other students were suggesting making this a positive 40 and a negative 40. So multiplying by 5 and 4, or negative 5 and 4. So anyways, we will talk more about this in class. Tomorrow we'll practice all the different methods of solving systems of equations. I hope the video was helpful, and thank you for watching. All right, bye.